We can extend our histogram analysis a bit to Excel, which is the most common tool people still use in industry. If we look at pump shaft B measurements here, we can use the chart tool within Excel, which is fairly new relative to how long Excel's been around, that they have a histogram function in here. So histogram, and the default histogram doesn't look too bad. We do definitely see a normal tendency in here and a few outliers as well. And so we could tinker with that a little bit. Another tip is to look more closely at the statistics and then to use the data analysis toolpath to make our own histogram. So one thing we might do is look at the count or N, and then some other stats. So let's look at the count of measurements in J, 186, and we'll also look at the max, min, average, median, and mode. And so we'll do max, J, that's 30, min, J, is 7.69. The average value of our pump shaft measurements is about 19.82. And so then the median, the central value, is 19.99, and then the most common value, the mode, is probably 20. Yep, so it's 20. So that can give us an idea of how to how the data is centered and the range of it. So with the data analysis toolpath, we need to create our own interval of bins, and so let's do that now. So let's say bins. We could start out with some value below the mean, and then add an increment. So let's say we go 15.5 millimeters below the mean. We could add this to be, let's say, 0.5, and then we can increase that to about 25. So if we have bins set from 15 to 25 in 0.5 millimeter intervals, we can now use the data analysis toolbox. So data and data analysis, if you don't have this installed, you can install it for your version of Excel. It comes with Excel, and we can look at histograms. So here our data is J columns, and our bin range is right here, Q. We're going to say that our data has labels, and we're going to output that data here, and then we're going to chart it. We could also make a Pareto or sorted histogram or a cumulative percentage as well, but let's just go ahead and create that histogram. Some data will be hidden by embedded charts. Okay, so here's what our histogram looks like, and it gives us a little more control over that. If we want to edit that a little bit, we can. Let's take a look at this guy and chart elements, and we could change that to have slightly different look or feel, but in general that's a decent looking histogram. Notice though that we have several values below 15 and more that will default in here. We can use the bin dent rule to define the number of intervals k for a given histogram, and so the rule is k equals 1.87 times n minus 1 to the 0.4 power, and then that's all added. 1 is added to that. And so if we want to create that, we could just do equals 1.87 times, second equal sign here, 1.87 times parentheses n minus 1 to the 0.4, and then add 1, and we get about 16 intervals as a default. So here, this is a little more than that. It's about 21 intervals right there. So we could change the binning pattern we use. We could get a little bit better resolution. Let's say if we started at 18 and then did equals 18 plus 0.25 and then just went up to 22. That should be right about there. We can create a separate histogram using the bin-dent rule for the intervals based on this. And so to do that, now we just go to data, data analysis, histograms. Our bins will change to this guy right here. And let's be a little bit more specific about this guy. And then our output range will change to be right over here. And then we'll go ahead and chart that. There we go. So similar looking histogram, a little bit more defined in the middle using the intervals 18 to 22 with 0.25 millimeters. We can still see some outliers at the tail ends here that we might consider removing. So that's how to use Excel, both the built-in chart function and the data analysis histogram function, to make histograms for our dimensional measurement part tutorial.